All right, let's get started on today's notes. Before you do actually get started on today's notes, make sure you go back to last night's homework, which was 3.1 to 3.2 homework. Make sure you've submitted it and checked all your answers. If you have questions, feel free to email me or send me a message on Remind 101. Okay, so what we're talking about today is properties of logarithms. So the first property that we have here is a to the log base a of x equals question mark. Okay, so instead of giving you what this is right now, I'm going to say, hey, I don't know how to solve this, so I'm going to rewrite it as a log to see if it helps me, just so that I'm not just giving you what it's equal to. So if I rewrite this as a logarithm, I write log base, my base is a, of, my of part is what it's equal to, so question mark, is equal to my exponent, log base a of x. So if I had to say, well, what's the question mark? The question mark is x. So this simplifies, long story short, to x. So what I like to look at it is if you have a base of a and then raised to a log with a base of a, that's just equal to the argument of that log. All right, next one, same idea. I'm going to present it in a similar way as the last one. So if this is question mark unknown, if I said, okay, I want to know what that's equal to, and I don't know, I can rewrite that log as an exponential function. So a to what power, or like a to the question mark equals, and then I have a to the x. So then I look and I see, oh, fill in the blank here, it's equal to x. So long story short, if I have log base a, and then my argument has a base of a and it's raised to a power, it's equal to that power. All right, the next one here is when you have log base a of and you have things being multiplied in your argument. If you have things being multiplied in your argument, you can split it up into two logs where the arguments are being added. So we have log base a of x plus, I can break it up into a new log, log base a of y. So if you look here, it was one logarithm where the arguments were being multiplied, and I can split it into two logarithms where the argument, it's split into two arguments being added where the arguments are split up. Now, you could probably guess what division looks like. So if you have if you have a log with the argument being divided, you can split it into two logs where those arguments are on the two separate logs, but they're being subtracted. So log base a of x minus log base a of y. Last but not least, we have a power here of r. So if you have a logarithm and there is an exponent on the argument, what you can do is you can bring the argument in front of the logarithm and multiply it by that logarithm. So this is equivalent to r times log base a of x. All right, so now what we're going to do is we're going to use those ideas there, those properties, to do each of these problems here. So this one here says I have log base a, let a equal common log of 3, let b equal common log of 6, write each in terms of a and b. So we'll start with this one right here. So right now I want, in the end, realize I just want a's and b's, maybe numbers in my answers. Right now I have common log of 18. So what I'm going to do is I'm going to look at my two arguments here, which are 3 and 6, and I'm going to say, how can I get a 3 and a 6 to be an 18? The answer is multiplication. So here's a step that people try to skip. They just put their answer as a times b. That is not correct. This breaks into common log of 3 times 6. So now I can say, all right, I can break this argument into multiplication, 3 times 6. That means I can break this into two logs. Common log of 3 plus common log of 6. So notice two arguments being multiplied were split up and written as two logarithms that are being added. Now I can replace log base 3 with a and I can replace log base 6 with b. If I do that, I end up with a plus b. Realize b plus a is also a correct answer, but an incorrect answer is a times b. All right, let's try looking at the next one. So in the next one, I have a 36. So I have to ask myself, how could I use a 3 or a 6 or just one of them using multiplication, division, exponents, anything to get 36. So I say to myself, oh, 6 squared is 36. So I'm going to write this as log of 6 squared. Now I can use my property that says, hey, that's an exponent right there. I can take it and write it in front as a multiplier. So I have 2 times common log of 6. And now I can replace that common log of 6 with b. So I have 2b as my answer. You could have also broken this into 6 times 6. That would have been log 6 plus log 6, which is b plus b, which is still 2b. So realize if you do it a different way, you should still get the same answer. All right, next one is 54. So at first glance, usually I have the class think, how can you get 54 using 3s and 6s, using multiplication, division, or exponents? After a while, usually someone will come up with the fact that 3 times 3 times 6 is 54, or 3 squared times 6 is 54. Realize these are equivalent. You'll end up getting the same answer no matter what you do. So I'm going to use this one right here. 3 squared times 6. So now I can break this into 2 logs that are being added. Common log of 3 squared plus common log of 6. I can now bring this exponent in front. Some people try to skip this and just try to say a squared. That's not equivalent. So now this 2 is in front. It's not here anymore. And I can replace the log 3. I have 2a plus log 6b, the end. All right, once again, using 3 and 6, how can I manipulate that to be a 1/2 using multiplication, division, or exponents? Common log of 3 divided by 6. When I have arguments being divided, I can split this into 2 logs, which the logs are being subtracted. So I have common log of 3, which is a, minus common log of 6, which is b. All right, last 2 in this section. Go ahead and pause the video and try these on your own. Come back and check your answers. All right, I have a 2 now, and I have to ask myself, how can I use those 2 numbers to get a 2? 6 divided by 3 is 2. So log of 6 divided by 3. Common incorrect answer, b divided by a. You're not replacing the 6 and the 3. You're replacing a log 6 and a log 3, which I don't have yet. So I can break this into log 6 minus log 3. And then I can see b minus a. Last one right here. There's several ways to do the last one. So if you did a different way and got the same answer, there's a great chance that yours works. So how I would do it is I would say common log of 1/3 is the same thing as common log of 3 to the negative first power. I can bring my exponent in front. So that's -1 times common log of 3. -1 times a, so my answer is -a. All right, the next topic is expanding logarithms, followed by condensing logarithms. So long story short, I want these logarithms, which are condensed, to look like these logarithms, which are expanded. When I'm condensing, I want these logarithms that are expanded to look like these logarithms, which are condensed. Okay, so the first thing I tell students is that I have to get rid of multiplication, division, and exponents. So I look here and I say, is there anything in the numerator separated by multiplication? There is. So I like to put a little dot there so I can see that that's 2 different logs I'm going to break that into. In the denominator, that I can't put any multiplication in there, so therefore it's just 1 log. So any term that's in your numerator, or any number, any variable that's in your numerator, that's going to become its own logarithm, and they'll be separated by addition. Anything that's in the denominator will be subtracted from your logarithm. So this first one right here, I'm going to start with the numerator. So I have common log of 2 plus common log of x cubed. So I broke the numerator into 2 logs. Now remember, it's separated by multiplication, which there's not a dot there to tell you that, but you got to know that. The next thing I realize is that I have an exponent right here, and I can take it and write it in front of that particular log. So I do that in 1 step. So I'm going to change that to x, and I'm going to bring the 3 in front of that log. Now I have y to the 4th in my denominator, so I can split that into its own log, but it's subtracted. So minus log, common log of y to the 4th power. Once again, I'm going to get rid of that 4th power, and I'm going to put it in front of that logarithm. Now you just have to check that it's done. How you check to see that it's done is you say, is there anything that I can simplify? Is there anything that I know that can be converted to like a number? Looking at this has a variable in it, so no. This has a variable in it, so no. And I don't know what common log of 2 is. So my answer is done here. Another way that I just quickly check is just to make sure if you look at all the arguments, they should be single terms. Unless it's like x plus 6, but you should never have multiplication located in those arguments. All right, let's try another one. So the first thing I notice is that I have a square root, which we haven't seen. So what you have to realize is that you can rewrite a square root as a power. So I'm going to cross it off like it never existed and rewrite it as x to the 1/2 power, and now I can get started. So I do have 2 things being separated by multiplication in my numerator, and 2 things separated by multiplication in my denominator. So I'm going to have 1, 2, 3, 4 logs. I'm going to have 4 logs when I rewrite this. So here we go. Log, notice the base is 2 on this, so it's not common log. Log base 2 of 5 plus log base 2 of x to the 1/2, but I'm not going to put that power of 1/2. I'm going to bring it in front of the logarithm. Now I'm in the denominator, so minus log base 2 of this one right here, which is 2, minus log base 2 of y cubed. Once again, since there's a cube there, I'm just going to write it in front of the logarithm. So every time I teach this lesson, someone asks, why is this not plus? Okay, so let's really quickly explain that. It's minus this entire thing, which is, then it's plus, but we distribute the negative. So I just say the general rule of if it's in your denominator, you're going to have a minus in front of it. So let's erase that. And I'm about to be done with mine, so for this problem. So first I'm going to look at all the arguments. Single, 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 single. There's no multiplication there, so I'm good. Now I'm going to look to see if I can evaluate anything. This time I notice that I can evaluate something. Log base 2 of 2. It's asking me 2 to what power gives me 2, which I know the answer is 1. So my final answer, log base 2 of 5 plus 1/2 log base 2 of x minus 1 minus 3 log base 2 of y. The end. I say the end a lot. Okay, next one has no division, but it does have multiplication. It's x squared times this. Once again, I'm going to get rid of this square root right here and bring this to the 1/2 power. So I'm going to change it to x cubed plus 2 to the 1/2 power. Now, first thing that people see this is they think they have 3 logs they're going to end up with. I am not going to have 3 logs I'm going to end up with. I'm going to end up with 2. There's 1 right here and 1 right here. There's 2 things separated by multiplication. This is addition. It doesn't break into 2 logs. All right, so this one's pretty quick here. I have natural log of x squared, but since it's a square, an exponent, I'm going to bring it in front, plus, oops, I've hit common log, I meant natural log. Natural log of, now I'm going to make sure I keep that x cubed plus 2 in parentheses. And I have a 1/2 power, which I will bring in front of that log. Looking at each, there's nothing I can evaluate. If I look at my arguments, this is just an x. This is an x cubed plus 2, which is absolutely fine. If it was 2x cubed, multiplication, it would not be fine. So that is my final answer. All right, last one in this section. I'm going to look in my numerator. I see these are separated by multiplication, and then there's nothing separated by multiplication in my denominator. I'm going to write my 3 logarithms. Log base a of 2 plus log base a of x to the 5th power, but I'm going to write the 5th times 5 in front of that log. Now I'm in my denominator, so minus log base a of, once again, this is an x plus 2. My exponent is 3, but I'm not going to write it as an exponent. I'm going to take it and rewrite it in front of my logarithm. So that is how you expand. Okay, those were using our properties here at the top, this one, and this one. And now finally, we're going to condense. We'll also do more practice on this tomorrow, just to make sure that we see it. So if you are, going through this pretty well tomorrow, there's only one that would challenge people that might be a little bit different tomorrow. So this one right here, that's the most challenging one. I want to make sure everyone knows how to do that. Okay, so this is 3 logarithms. We want to make it a single logarithm, 1 logarithm. So the first thing I do is I start writing log base 2, because that's what they all are. Then I look and I say, is this going to be a fraction as an answer? Meaning, is the argument going to be a fraction? If I see subtraction, that means that there is going to be one. That means that there's a denominator. So I do that next. All right, now I look at each of my arguments. So this is an x. This is positive, so it goes in the numerator. I'm going to look to see if it has an exponent. There's no number written in front. In fact, there's a 1 that's implied there, but I don't need that. If there was a 2 here, let's say, I'd say that's x squared, but it's not. It's a 1, so it's x to the 1st power, so I can put an x in my numerator. All right, now I'm going to look at my next argument, which is y. Look for an exponent. There isn't one that I need to write in. So I'm going to write my y in my numerator. Notice I'm not putting a plus sign right here. I'm condensing it. That means that I can, if 2 logs are being added, I can change it to 1 log where the arguments are being multiplied. Finally, I go to my last argument, which is z. Once again, no exponent. It's in my denominator. I would also look to see if I can simplify that fraction at all. That fraction's not simplifiable, so this one's done. All right, next one right here. This is all common log, so I'm going to write down common log. I see minus signs right here. So I'm going to put a fraction bar for the division. All right, I'm going to start with my first argument. This is an x. It does have an exponent, which is squared. So I'm going to put an x squared in my numerator. My next argument is a 2. It does have an exponent. It's a cubed. 2 cubed is 8. So I know there's an 8 that goes in my numerator. This is a coefficient, so what I'm going to do is I'm going to move this x squared over. I'm going to put the 8 in front of it. All right, next I have everything else is in the denominator because it's a minus and a minus. So I look at this argument. It's a y. Has no exponent because there's nothing right here. And then I look at my final argument, which is a 4. That goes in my denominator because it's a minus right here. All right, now I'm going to look to see if I can simplify this fraction. This fraction is simplifiable because I can simplify 8 divided by 4. That's 2 over 1. So my final answer is common log of 2x squared over y. All right, so the next two, I would say go ahead and you try the next two, but this is what's you have to evaluate that. If you want to go ahead and try it, and then when you get to the evaluation part, look back at my video. So you can go ahead and pause and try it, and then come back and see how you did. Okay, so this is how you do this next one. This is natural log, so I'm going to write down natural log. I see minus, minus, so I know that there's going to be division. All right, so I have 9 to the 3/2 power. 9 to the 3/2 power, and we can eliminate that. Or sorry, we can evaluate that. All right, so now notice this is a minus right here, so now I'm in my denominator. X to the 5th power. Minus again, so notice I'm in my denominator again, 9. I wrote it in front because it's a coefficient. Now this is back to a plus right here, so this is back in my numerator. I have the argument of y in my numerator. All right, sidebar, 9 to the 3/2 power. Recall from Algebra 2 that when you have 9 to the 3/2 power, one way that I used to teach my Algebra 2 classes is that this right here and this right here, how I can think of it is you can think of it as a flower. Oh, that's so beautiful. So here is the ground. Here are where the roots are. All right, so the roots are on the bottom, and here's your flower power up top. So in other words, this is your power, your flower power, and this is your root. So that means square root, since it's a 2, and then cube. That's your power. So I'm going to square root the 9, and then I'm going to bring it to the 3rd power. Square root of 9 is 3. 3 to the 3rd power, 27. So that I can change to a 27. So now I have natural log of 27y over 9x to the 5th. I would be done if that fraction was not simplifiable. 27 over 9 is simplifiable. 9 goes into both. So my final answer is natural log of 3y over x to the 5th. All right, pause the video and try the next one. All right, check your answer. You should have log base a of 4x. This whole thing is to the 3rd power. Realize this logarithm wasn't completely split up. Then I have in my denominator x plus 8 to the 1/2 power. Now you can put 1/2 power or you can do square root. Both are correct. One thing that you do want to do is you want to make sure that you expand this. This is 4x times 4x times 4x, which is 64x cubed. So my final answer is log base a of 64x cubed over square root of x plus 8. Once again, you can leave the x plus 8 to the 1/2 power. All right, last but not least, we have our last problem that's a little bit different. So what you should notice that's different about this is that this is a log base 3 of 4. This is a 2 log base 3 of x. This is a 5 log base 3 of y. It's not y plus 1. If this was y plus 1 like this, it'd be just like the ones that we've been doing, but it's not. So this right here is not a logarithm. So what I want to do is I want to make that a logarithm. There's several ways to do this. I think the easiest way for people to see is I want to make this a log also right here. So I'm going to do log, whatever the base is. They're all 3, so I'm going to do 3. And then I need an argument right here. I need to make sure that I'm not changing the value of this, meaning this still has to have a value of 2 because that's what it was. So I want this to be a value of 1 because 2 times 1 is 2. So I say, okay, how can I make that a value of 1? The argument would have to be 3 also. Log base 3 of 3 is 1. 3 to the 1st power is 3. So that's what I'm going to change it to. So the hardest part for people is to now pretend that this was typed on your paper. This was here. So if you can pretend that, or if you can just type it, like you can change to keyboard and type it, then you'll be okay with it. I'm ready to write my log now. Log base 3 of. I need a fraction bar because there are minus signs here. All right, my first argument is a 4. This is positive with no exponent, numerator, 4. Next one, negative. So it's denominator. Exponent is a 2, so x squared in the denominator. Next one, positive, so numerator. Y to the 5th, y to the 5th in the numerator. Last one, positive, numerator. Exponent is a 2, 3 squared is 9, 9 in the numerator. So I'm going to add the 9 right here. Notice I put a multiplication, not an addition sign. There shouldn't be any addition in your answer unless you see a set of parentheses like so. Okay, so clean this up and we'll be done. Log base 3 of 36 y to the 4th over x squared. That fraction is not simplifiable, so this is done. You can go ahead and start today's homework. Today's homework is bookwork. The answers will be posted after 1 p.m. tomorrow, so make sure you get it turned in by